Welcome and thank you for joining us for today's webinar. Built to Last is a legacy that solves today's mud pump problems with precision engineering. I'm Mary Brinkman, Director of Operations at American Mud Pumps, and I'm honored to introduce a discussion that isn't just about mud pumps. It's also about innovation, legacy, and making smarter decisions for the future of drilling operations. Just a few names in the mud pump engineering can carry the weight and influence of the industry, and Williams family is definitely one of them. Their expertise has shaped the industry for over 80 years, revolutionizing how operators approach efficiency and reliability. The story begins in 1942 when Ellis Williams pioneered mud pump technology, setting the foundation for what would become an industry-wide transformation. Over the decades, his work influenced major manufacturers such as Idaco, Imsco, and Skytop Brewster, and his impact ultimately led to the development of the most recognizable brands in the world, Luico, a joint effort between Letourneau and Ellis Williams Company, Inc. Later, the Williams family played a significant role in the Awico Ellis Williams Engineering Corporation, a company dedicated to precision engineering pumps, which was eventually acquired by Weatherford International in 2008. These advancements didn't just shape the industry. They set new standards for durability and efficiency in drilling operations. His legacy now lives on through his grandson, Jason Williams, our presenter today. Jason is a leading expert in positive displacement piston pumps, having apprenticed underneath Ellis Williams and his father, Michael Williams, at Awico. Over the years, he was honored with his skills in mud pump design and engineering, earning multiple patents for his achievements. Most notably, he spearheaded the development of the roller bearing continuous duty internal gear quintuplex mud pump, pushing mud pump technology beyond its conventional limits. This session will dive into costly failures that plague unreliable mud pumps, the hidden inefficiencies that drain drilling operations, and the precision engineering solutions that eliminate downtime and maximize productivity. We will have a Q&A at the end, so please hold all of your questions and they will be answered. This isn't just about technology. It's about making informed strategic choices that impact your operations success. Let's get started.
Good morning, everyone. In relationship to mud pumps, one of the primary problems with mud pumps is they are one of the top 3 of NPT, which is non-productive time on a drilling rig. They are the cause of NPT, which is non-billable time, and essentially downtime for both the operator and the energy company that they're working for. One of the primary problems with NPT, with non-productive time, is the quality of the pumps that some people have. There are ways to extend NPT to where you don't have as much of it, but there are still some issues that exist. We're going to hit both of them. One is on the fluid end, the other one is on the power end. The fluid end, one of the easy ways to extend non-productive time is to go from chrome liners to zirconia liners. The other way to do it is to make sure that your mud pump has an intermediate rod that allows you to change out your pistons in your fluid end without having to change out your liner. Typically, you'll go through 2 or 3 pistons per liner, and it just takes more time to change them out if you're removing the liner and the piston both at the same time, every single time. The zirconia liners are the solution to longer liners. There are some pistons that last longer than others. Primarily, you want to pick your piston for your fluid that you're running through it. The other thing that goes out is on the fluid end is the suction valve and the discharge valve. Those are maintenance items as well. You will go through suction valves at a rate that is faster than discharge valves. It's also, you need to choose the type of fluid end for your mud pump that is best for that. Typically, that's one that has a separate module in either a vertical position or horizontal position. And we offer both. Compared to a valve rubber valve. Valve rubber valves are useful. They are smaller and they still get the job done. They just take a little more time for changing out suction valves. So the other issue is, we'll lead into the second part of the topic, is the power ends. Power end problems have to do with quality of the build, type of pumps that are built. You want to have a quality, well-built power end that will last you years. Ideally, your power end should last you somewhere between depending on what you do, 8 and 12 years between overhauls on a quality power end. Some manufacturers do a better job at that than others. We have pumps in the field currently that have been operating for over 20 years without overhaul, and they're halfway through their life expectancy. Unfortunately, the adoption of foreign-made products from the Far East have really cut down into non-productive time and a quality basis that ranges from, I've seen everything from gear failure to misalignment of crossheads in the power frame, to bad machining on the power frame, to crankshafts that aren't machined between centers, which is a big issue. And it's, even though you have some of these foreign made products may be cheaper on the initial end of it, they're not cheaper in their overall cost of ownership. You have to look at total cost of ownership over the life expectancy of the equipment. If you're replacing a mud pump every 6 months to a year and a half because of a power end failure, it doesn't make sense for the mud pump. You will spend more money over time than you would if you buy a quality one on the front end. Cast crankshafts. All cast crankshafts will fail. I don't care who makes them. It is all cast crankshafts will end up failing in the field at some point. When the crankshaft fails, the cast crankshaft fails. It's not just replacing a crankshaft. At that point, you're overhauling the pump itself and typically replacing bearings. And if it is a catastrophic failure, it depends on when you catch it. If you catch it early and you catch it when the crankshaft has cracked, you're able to strip it down. At that point, you're just looking at bearing replacements on the eccentrics and the mains, along with a crankshaft replacement. If it's a catastrophic failure, you're looking at a complete crash kit. The complete crash kit consists of bearings inside of the pump, a replacement crankshaft, possibly a new gear set, and it's a complete overhaul. And that it is expensive and it is costly, and you will have downtime in your pump because of that. If you initially start out with a pump that's crankshaft is forged, balanced from an alloy steel forging, a forged balanced, we produce a forged alloy steel weldment, which was originally invented by my family over 40 years ago and is essentially fail-safe. You don't have that problem. All of our crankshafts that we produce for our continuous duty drilling pumps are designed to last the life of the pump itself, to where you don't need a spare, you don't need a crash kit. We don't have that issue because of our forged crankshafts. Yes, they may cost a little more, but the peace of mind at the end of the day and that your mud pump is going to operate successfully is really where you want to be, especially in the field. Crosshead misalignment is the other issue that I've seen. Crosshead misalignment is done. It is critical for the expenditures of liners, pistons, and the life expectancy of liners and pistons within your mud pump itself. Crosshead misalignment can be brought to where you, at the middle of the stroke of your crosshead, to where you're within 5/1000th of an inch of the inside of your liner. Ideally, you want your piston within your liner to do a random orbital search within the liner. So it will actually wear the liner evenly all the way around the liner inside of it. The other issue is that some people have is gear failure. You see a lot of manufacturers who use helical gears or double helicals versus a herringbone. All right. The herringbone, traditional herringbone standard is HEMA 42401. 42401 may be an out of date standard. However, it is the ideal standard for a triplex mud pump. All right. Other gear standards have their place, but you have to look at a triplex architecture. You have an open power in that the gear operates in, so the gear is not isolated by itself. Herringbones are self-aligning, and they are through hardened. So if you end up with debris inside of your power in and it ends up going through your gears, it will not eat through your gears. The other problem with double helicals is that most people don't pay attention to the way that they're manufactured. You have three surfaces that need to be perfectly parallel in a double helical compared to one in a herringbone. The herringbone, the teeth are cut at the same time, and they're cut on a jig to where you end up cutting the left side and the right side, and the gear is mounted there. So your two side plates of your gears are just references. On a double helical, where it's hob cut, the gear itself sits on a table, and it has to be perfectly parallel with the other side as well as with the internal main flange in order to be able to get that gear to run true to itself on the crankshaft and to its pinion shaft, because they end up being manually indexed in. So if you end up with a deviation from a parallelness on the sides of your gears during the initial rough out cut, your gears will not be cut straight on the gear set within your pump, which will end up with misalignment. So that's one of the problems that I've seen with gear failure. The other issue that I've seen with gear failure is that it ends up going from a negative backlash to a positive backlash. That is either due to the concentricity of the gear being off, or I've even seen it to where the crankshaft itself was not machined between centers and was making that plus or minus within the gear set. And what you end up with is a backlash. Your gears need to never go into a negative backlash to where they end up pushing off one another, because what you will end up with is a premature gear failure within the pump itself. So, but the other thing on the power end that you need to look at is the architecture that your power end is manufactured with. Forged steel plate weldment power ends are superior to cast power ends. They always are. Your power end is constantly in tension. All that pump wants to do is push your fluid ends off of the front of your pump, and so your castings are inherently better in compression, whereas forgings are better in tension. Because your power end is constantly in tension, you want to make sure that the power end that you purchase for your pump is not cast, or castings are, I know people do them and they do it for cost reasons, but they're not superior to forged alloy steel weldments for power frames. The primary difference between the manufacturing process, actually, these things are large sewing machines. Even though your mud pump, 1,600 horsepower mud pump, may weigh somewhere between 30,000 pounds and 65,000 pounds, these are really large sewing machines in their precision of both manufacturing as well as assembly. And the quality of both the manufacturer and the assembly that we have at American Mud Pumps is superior to none. We produce some of the highest quality pumps in the world that are field proven to outlast any of our competitors. And one of the things that I've actually found is interesting that's been coming up quite a bit is we've been asked to how we would approach 10,000 psi fluid ends versus 7,500 psi fluid ends. One of the big moves that's happened in the last decade is everybody's moved from 5,000 PSI fluid ends to 7,500 PSI fluid ends, as drilling operators are required to drill further out on longer laterals at higher pressure. One of the things that we've been asked about is how we would handle a 10,000 PSI arrangement. 10,000 PSI drilling pumps are very doable. The real limitation with 10,000 PSI versus 7,500 PSI is the API SA4 piston. SA4 pistons within their existing architecture at 10,000 PSI, the experiments have been done already in the field, and their life expectancy is measured in hours instead of days. One of the best approaches to this is to have a hybrid system, in my opinion, even though there are other approaches that exist. But one of the best approaches is to have a hybrid system, or what I would refer to as a hybrid system. The hybrid system would allow you to run a traditional piston and liner, either chrome liner or a zirconia liner, inside of the mud pump at lower pressures, but also allow you to take out that piston and liner and install a plunger and packing system within the fluid in itself, or within the liner area itself, to switch over to a plunger and a packing system for a 10,000 PSI application. One of the things with 10,000 PSI that you have to be aware of as well is back to crosshead alignment. Your crosshead alignment has to be extremely precise between the middle of your crosshead into your fluid and liner box area in order to be able to withstand in order to be able to get longer life and get the needed life expectancy out of a plunger and packing arrangement at 10,000 PSI. Plunger and packing sets have been around in the oil field for years, and they've improved dramatically, primarily due to fracking operations. Hydraulic fracturing has taken those systems well beyond where they initially were, even 20 years ago, into where they are reliable and efficient operational systems at 10,000 PSI for mud pumps. You can set your mud pump up initially for a 10,000 PSI application. And when the time comes and your customer asks, because it's been happening, we've been getting those questions as to how we would approach it and how we would handle a 10,000 PSI. We at American Mud Pumps can set you up with a 7,500 PSI system that can be converted into the future into a 10,000 PSI with changing out the piston liners into a plunger and packing. And it's what we call the hybrid system. The other thing that can come up is, yes, we do offer crash kits. I know I spoke of this earlier, crash kits for other people's pumps. At some point in time, if you're operating a Continental IMSCO based triplex that was manufactured overseas, or a 12P160 National, or Garner Denver PZ11 with a cast crankshaft, we have the ability to offer a forged steel alloy balanced weldment that is superior to the casting, that will be a drop-in replacement for you, so that when your cast crankshaft does fail, you have a replacement crankshaft on site, one that is made in America, one that comes with a lifetime guarantee, that when you end up replacing it within that pump and rebuilding that pump because of a cast crankshaft failure, you will never have to deal with a cast crankshaft failure again. And that crankshaft will end up outlasting the life of the remainder of the components within that pump for the remainder of that pump's life. One of the future innovations that we see as being the next wave of reciprocal pump technologies and drilling pumps is moving from triplexes, which has been the industry standard since the 1960s, because let's call it what it is. My grandfather was one of the first to put single acting triplexes into mud service back in the 1960s when he was the chief engineer of Continental IMSCO. But we see the next generation of mud pumps being the Quintuplex pump. Quintuplexes, all of our Quintuplex mud pumps that we manufacture and build are made here in Houston, Texas. They are gear drive. They are superior to triplexes. They do not require dampening on either the suction or the discharge. They tend to be smaller, lighter. They're more easily transportable, and their packaging is easier. One of the things that we see is that even though there are two more cylinders, and these are units that have been in the field now for close to 15 years, is that we do not see a rise in consumable consumption versus a triplex. One of the things that everybody says is your quintuplex will use more spare parts. It really does not. But what it does have is you take that discharge dampener off, you take the suction dampener off. The quintuplex itself doesn't create the mud noise problem that a triplex does. It ends up, through its architecture on the power end, ends up compressing the wave of the discharge and raising the discharge frequency all at the same time. What does that do for a drilling operation? It makes it to where you have better MWD, LWD data retrieval from downhole, and it makes it to where your directional drilling finding is superior to any triplex-based system that exists, because it eliminates the mud noise that exists inherent to the system and inherent to the triplex pump itself. What you will find is that you will pull hole less, you'll have to drop a wire line less, and your directional drilling will be significantly clearer because your signal return from downhole is also superior. The other thing that we have found is that sometimes, depending on what your specifications are, you can put two quintuplexes onto a rig and operate it as if you have a spare triplex without the need for a spare. The reason why I say that is you install two American mud pumps, 2,400 horsepower quintuplexes onto a land rig. That is the equivalent available horsepower of three 1,600 horsepower triplexes. Those 2,400 quintuplexes sit in the same basic footprint as your 1,600 horsepower triplex, and those two pumps will outperform the three 1,600 horsepower pumps from both a volume and a pressure basis in most drilling operations. One of the things that I've always emphasized in the products that we manufacture is efficiency, transportability, and a superior product. There are ways that you can make a pump lighter, faster, and outperform anything else that exists on the marketplace. One of the ways is to stroke the pump. Our 1614 is a 14-inch stroke, 1,600 horsepower triplex pump that is a traditional triplex pump, but it has within it, just because of making the 14-inch stroke versus a 12-inch stroke 1,600, you get inherently, to the architecture of the system, 1/3 longer bearing life. You get 10% longer consumable life, and you get a more reliable and longer lasting pump overall. How do we do that? By slowing it down from a 120 strokes per minute 12-inch stroke pump to 110 strokes per minute 14-inch stroke pump, your rod load goes down within the pump itself. Every loading surface within the pump gets loaded less and less frequently. So therein you get 1/3 longer bearing life when compared to a 12-inch stroke pump. In the consumable basis, that reduction from 120 strokes a minute to 110 strokes per minute gives you longer consumable life within your pistons and your liners and your valve seams and springs, because your consumables are changing direction less. So you end up with longer lasting consumables and a longer lasting power frame just by using a 14-inch stroke versus a 12-inch stroke. The other way that you can increase your efficiency is by speeding your equipment up. Cast crankshaft power frames do not have this ability. However, if you have a balanced forged crankshaft within your triplex itself, you have the ability to overspeed your pump. As long as you're within the parameters API 674, you can do this. By speeding your pump up, you also lower your internal loading within the pump. We have certain models, like we have what we call the 1600L, which is a 1600 horsepower, lighter weight construction unit, which is still a double wall construction, 12-inch stroke pump, but it weighs 31,500 pounds compared to a traditional 55 to 60,000 pound triplex. How do we do that? We take your 12-inch stroke pump, and instead of running it at 120 RPM, we recommend that it's running 140 RPM. By speeding the pump up, but still being within API 674 parameters, you're able to shrink the overall profile of the pump, shrink the overall transportation weight, and make for a smaller, lighter, more high performance piece of equipment for applications in the field. One of these 1600Ls, we would recommend being powered by a single motor rear set 1600 horsepower pump or 1600 horsepower AC motor through a belt drive, which is commonly available. The other way to get more bang for your buck out of the pump is to go from a triplex to a quintuplex. Quintuplexes, we believe, are the next generation and the superior product within the industry that, when compared to a triplex, is how the drilling industry itself will be going into the future through smaller, lighter, less stroke, more cylinders, quintuplexes that do not require suction or discharge dampeners. Are there any questions that I can assist you with now?
So, Jason, if you're ready, I'm going to go ahead and ask the first question.
Go right ahead, Mary.
All right, the first question is, in what types of drilling operations does a quintuplex mud pump outperform a triplex mud pumps in terms of efficiency and reliability?
All of them. For the short answer, for the long answer is the quintuplex. It eliminates the need for both pulsation dampeners on the suction and the discharge by smoothing out the discharge flow of the mud pump itself. Also, the quintuplex inherently gives you the same performance chart that you get in a triplex, but also you get a volume chart. So, say a 2200 horsepower, 2400 horsepower triplex, you're going to max out at 1100 gallons a minute, 1200 gallons a minute, versus a 2400 horsepower quintuplex, you'll max out above 1600 gallons a minute capability, but you will still get the pressure chart and that you would get the 7,500 psi or 10,000 psi if it's set up for that initially, that you would get on a triplex. What essentially it does is it gives the operator more pressure bucket options during operations.
Thank you very much. We do have another question over here, and that is, let me just, okay. Here it is. The next question is, does American Mud Pumps do mud pump packaging?
Yes, we do mud pump packaging, diesel drives, electric, even turbine drives. I've worked on those before. I have worked on a steam powered pump. We didn't build it, but we made the proposal when it was requested. But yes, we do all types of configurations, all types of packaging. We will assist you in packaging the pump. We will sell either a bare shaft pump or a packaged pump or anything in between that you would like us to. We are here to help in any way that we can.
Great, thank you. And I have another question here for you, Jason. It says, what are the key advantages of choosing a continuous duty mud pump over an intermediate duty mud pump for drilling operations?
Well, intermittent duty mud pumps traditionally are the larger horsepower ones are frac pumps. You get two types of bearing selections within pumps. You get sleeve bearing and you get roller bearings. Continuous duty drilling pumps are all roller bearing constructions. Frac pumps are sleeve bearing construction. Even though you will get an ultimate higher rod load out of sleeve bearings, they typically have a much shorter life expectancy. The longest sleeve bearing design life expectancy that I've seen is 10,000 hours of life expectancy between overhauls. Whereas it's not uncommon for a continuous duty drilling pump to get 100 to 125,000 hour plus in between overhaul intervals. And that's just because of its bearing selection. Roller bearings are anti-friction bearings versus sleeve bearings, which are friction bearings. Also, roller bearing pumps run at a much higher mechanical efficiency, so they don't disperse or displace or create heat the same way that a sleeve bearing pump does. That heat tends to degrade the internals of the pump as well as the oil, and so it shortens the life expectancy. So even though some people have tried to put sleeve bearing pumps into mud service, the industry standard and the choice that we all should be making is roller bearing.
Okay. Thank you, Jason. We have another question here. It says, under what climate and temperature conditions is it possible to reach 10,000 PSI?
10,000 PSI is really two factors when it comes to climate and temperature from a hot end and a cold end. Of course, you're going to have a winterization package in some type of Arctic condition. But it really, your maximum temperature is going to be somewhere between 250 and 300 degrees Fahrenheit, which is, correct me if I'm wrong here, I believe 150 Celsius. That's typically where I like to rate them. If somebody's got a special condition application, we can work with that. But as I mentioned earlier, roller bearing continuous duty drilling pumps don't generate the heat sleeve bearing units do. So we often supply pumps into 50, 60 degree ambient temperatures where that is the ambient temperature of the operation of the mud pump. And it doesn't matter from a plunger and packing or piston and liner basis. It really matters the temperature of the fluid that you intend to be pumping inside with the plunger and packing. There are packing sets that will go up to 400 degrees that I know about. We haven't installed those, but it's not out of the realm of possibilities. We like to tell people though that as long as your fluid temperature is under 300 degrees, which is 150 degrees centigrade, we can help you with your application reasonably.
Just wanted to let everybody know that if you do have any questions, you just submit them up in the upper left where it says Q&A, and we'll try to answer everyone's questions. We're going to move on to the next question, which was, how much electric power for the types of pumps do you have that you are providing?
How much electric power? It really is depending on the size of the motor. You have dual drive systems where you're powering the pump by two either AC or DC traction motors, which are GE 752 based frames. These are locomotive motors, but in the last 20 years, motor technology has really advanced to where you can get a 5,000 horsepower AC motor that will perform. It's really the power demands and the electric demands are really based on your motor that you need to supply and based on the horsepower and the amperage of your motor. We've done 460 and low voltage and medium voltage motors are not uncommon.
Okay.
Well, let's have a discussion about your next project. We love to help our clients. We love interesting applications. We have a broad product offering here at American Mud Pumps, and we would like to be considered as your strategic partner in your next application for your next positive displacement pump requirements. I would like to invite you to our booth at OTC and to come to us and have a discussion. We're here to help you in any way that we can, and thank you for your time.
We've covered the legacy that built our expertise, the common pitfalls that cost operators millions, and the smarter choices for the future. As Jason highlighted, making the right decisions today will impact performance downtime and overall probability to win. But we're here to continue the conversation beyond this session. Our team is excited to meet you in person at the Offshore Technology Conference in Houston. We will be at booth 770 from May 5th through the 8th. Let's talk before your next project gets locked in. Precision engineering isn't just a concept, it's a necessity. Thank you for joining us, and we look forward to connecting soon.